plan today is to finish up. So last time we did the we did the start of this beginner stuff, and I wanted to get into NREPL, into the REPL and NREPL, but we never got there. So I'm just taking everything that we're going to talk about that night, putting it here, and then we'll try to make this like very interactive. So I'm going to stay completely here at the command line. We'll go through it. So what I'd encourage you to do is to kind of play along and get into your terminal and try things out. At the end, we'll kind of do some. We'll kind of have some fun doing some of the shared NREPLs and things like that. So I thought I'd get started. But I guess first, did anybody have any announcements or anything that they wanted to, or questions they wanted to ask before we get started? No?
Doing a hack day anytime?
We've been, things have been pretty busy for me, so I didn't organize it, and I told Sam if he wanted to. If one of you guys wants to, I mean, I've been traveling a lot. If one of you guys wants a hack day, mention it to me or Sam, and we'll put it up. I'll be there if I'm in town. I just didn't want to, put something up and then end up being traveling during those days. But we can put one up, and we still have the class coming up. We're just waiting on the room, but we're still planning to do this Lispcast Introduction to Clojure at Tech Shop. So I just need the dates that we are going to do that from Tech Shop, and then we'll be able to schedule that. And next month we have Cassandra. So Nick Bailey, one of our old members from the group, he works at Data Stacks. And he's going to come. He's going to give a little introduction to Cassandra, and then he's going to show some of the Clojure libraries for accessing Cassandra. But we have time at the beginning for a short talk. So this is if there's something you want to show, then let me know, and we'll schedule that in, because I think that would give us some nice variety for that month. All right, so getting started with the REPL here. Okay, so. If you're doing any Clojure, I think you've probably already understood that like the REPL is one of the greatest things about Clojure. Being able to interact with your environment, being able to interact with your code to me is like the single greatest feature of Clojure, at least in terms of developer experience. So what I'm going to do is I'm going to start up a new project. Actually, I just created one just before to do it, so I'm just going to use this. This was just a brand new project, and I was going to show you like, okay, well, where does the REPL come from? There is actually I'm going to mostly focus on NREPL today, but there's actually a core REPL built into Clojure itself. The first thing I was going to say is how do we get that? So first thing is, so last time we talked about line, right? And so we saw line that we could get the class path for something, right? For our project, so line class path. And in here is the Clojure jar. So this guy right here, so line class path, it gives me the Clojure jar. And if you just run the Clojure jar, java-jar, you get the default Clojure REPL, right? So it's built into Clojure. You do all your, right? Yeah. Do all of the normal things. Now, you'll notice I don't have any line arrows, I don't have any editing, right? There's no, it's just as like, just a raw REPL. What's nice about this is that this works for anything you're doing. So anytime you're doing anything at all, whether it's Clojure, whether it's Java, you can actually pull up the Clojure REPL and use it, right? And if you don't want to run it as a jar, by the way, it's just as long as the Clojure jar is on the class path, you just run clojure.main, you get into the REPL, right? So this is actually interesting because let me put this in an environment variable so I can access it, and I'm going to pull up another jar. So I'm going to pull up something like hypersonic here, right? HSQLDB, I mean, and just to show you the example of using this with another jar. So if
any danger to trying this with Clojure 6 or Clojure 1.6?
No. In fact, yeah, I should probably be using. It's just like the current Leiningen 2.3. The Leiningen 2.3 still is it defaults to Clojure 1.5, and there's no, as far as I know, there's no differences there. So let's say if I did something like this, if I java-class path and I put the Clojure jar and the hypersonic jar on the class path, right? So just simple environment variables. Then I run Clojure.main. Okay, so I'm into the REPL, and then if I run, so now I can actually just interact with my Java code directly like this. Java data. I gotta look at my notes here. Database.
I'm gonna go find the hypersonic jar.
Yeah, this is just an example, right? Oh, and actually, this is a main, so I can't actually call it like this. I have to give it a string args. So into array. So this is really ugly Java interaction here. Is that up and going? There we go. And here's a hypersonic or HSQLDB is running, right? The interesting thing is running, so this is normal Java code, but I still have my Clojure REPL around, so I can interact with the environment in my Clojure REPL. So this is actually kind of an interesting thing here, because even if you're just working with regular Java code, you can still add, as long as you bring in the Clojure jar, you can bring in the Clojure REPL, and all the things I'll show you, everything from being able to interact with things to load new classes, you can actually do. You can reify Clojure classes into your Java stuff. So even if you're not doing Java, even if you're not doing Clojure day to day, if you're doing any Java anything, you can probably still make use of the REPL. But this REPL is actually not terribly interesting by itself. So we're going to spend most of our time talking about NREPL. But since I was in Clojure main, I thought I would show a couple other things that you can do with it. Namely, because I think I'm not sure if everybody knows. So it's actually Java-jar. So if I run the Clojure jar again, and then I say you can pass it you can pass it any arbitrary Clojure code, right? And you can just run it. So if you're trying to call some Clojure from a script or something, and then of course if you have a Clojure file like so if you've got just a standalone script like that, so java-jar, run the Clojure jar, and then you pass it the file name, and it will just run it. So that's sort of how you can, if you've got Clojure around, you don't need a Leiningen project to do anything. You can just hack around quickly with it. So I thought I would mention that just because it took me, it's one of those things I didn't really know how to use Clojure at the beginning. I just used Leiningen, and I didn't realize how easy it was to actually make use of some of this stuff. But we don't want to really do that. What we really want to do is use the Leiningen, use NREPL. So I'm gonna start NREPL with Leiningen. So when I do line REPL, it starts a Clojure REPL, and it's the same Clojure REPL that we just saw, but it's got a little bit of stuff around it. So it's got the ability. So if I do things, I can actually go through. You've got your command history, right? And you can go back through your history, and I can move around in the line and edit it, right? Now the key bindings here are Emacs style, so Control A, Control E, Control K, that kind of stuff. If what I didn't know, so here's something that I don't think very many people know at all. If I go into my /.input.rc and I say set editing mode VI.
Why would you do something?
What? No, I'm an Emacs guy too. But
I'm a VI guy, and I never do that.
yeah. So now, my Control A, Control E doesn't work, but I've actually got a mode where I hit escape and I can come in and do VI style key things, right? So I just thought I'd bring that up because I think some people aren't terrible, have never seen that. I didn't actually know this existed either, but it's part of readline. Yeah, it doesn't actually use readline from what I understand, but it mimics the input RC from readline. So now I'm going to go change that back because I do not want VI editing mode. All right, so what else is interesting about NREPL compared to the normal REPL? The first thing is, and let me pull up another window here.
How did you do that?
What?
How did you do that?
Oh, this is split terminals in iTerm. So I can split it this way or this way with Command D or Command Shift D. Let me back out of all of these. So that, or just Command D for the vertical split.
Thank you.
Because so by the way, yeah. So this is actually how I develop. This is how I develop Clojure. By the way, I run Emacs in terminal mode. I know a lot of people run like a GUI Emacs, and it's a little bit of a pain to set up. Get all your key bindings set up. But the ability to do the full screen here, see I can switch back and forth, and the ability, tabs and this, and to have my editors fit in is, I find extremely compelling. So here's. For example, here's my actual work environment here. So I will usually edit my code here, and then I usually will do get things here, and I will do my I will run the server or do whatever I need to do down in this. So sort of set up my own sort of development environment in there, and I find that if I try to use the GUI text editor, by itself, that's not part of an IDE or something, I find that it doesn't give me the sort of nice experience I'm looking for. Is that the project I'm in here? Hold on. Oh, I'm in Space Cadet. Sorry. I don't even know what directory I'm in. So what I was trying to show you here is what are some of the differences between the two here. So where did that Clojure jar go? Here, I'll just do it here. So if I do java-jar. When I hit, for example, if I hit Control-C, it just exits out, right? This is with the default Clojure REPL, right? Without NREPL. If I'm doing a long-running computation, there's no way that I can abort it, for example. Whereas in NREPL, when I hit Control-C, all it's doing is stopping the current operation. So if I were to have something that was something that was, say, a thread operation or something that was a long-running computation, you hit Control-C and it's actually smart enough to stop the current evaluation. So one of the good things that it provides. Another thing it provides is completion. So tab completion. So if I do Clojure and the tab, and then the REPL will give me command, give me all the possible completions. It will go into namespaces. It will also do Java, so string slash, like that, or Java util array list, right? So it'll do all of your Java completion or Clojure completion, and it does that by adding in the Clojure complete library. But it's extremely nice. It's another one of those nice things. So if you weren't aware of that, tab will do it. It won't complete nothing, but if you type the beginning of something, it will find it out, right? All right, so we're in the REPL here, and so I want to show some of the things you can do in the REPL before we get into actually NREPL and doing this over the network. One of the most common thing, one of the most nice things, if you're not using an IDE or you're not using Cider and Emacs or something, is you see these commands here, right? You you see something like macro, that's a good one, macro expand, right? And it's like, well, what does that do? Well, we've got the default doc, we've got docs in here. So you type doc, and it shows you the docs, right? So last time somebody asked, and I wasn't entirely sure, but I did some research to make sure I understood how all this works. So I thought I would show like, where do these docs come from?
Source.
Yeah,
the doc string on the actual.
The doc string, but where does the doc string go? This was the question we had. Maybe it was downstairs.
I thought it was a property on
the metadata.
object.
The metadata, right?
Right.
Right.
But
So,
where's the metadata?
well, the metadata is part of Clojure. The Clojure store keeps metadata for objects, right? So how do you get the metadata for something? So meta. Okay, so you get the metadata. So a normal object, if I just pass in a normal object, it's not going to have any metadata, right?
Right.
So this is Clojure metadata. If I pass in the var, now I can't pass in the function. If I pass in macro expand, that's a function, right? The function itself doesn't have the metadata. The var has the metadata, so that's why I'm var, yeah, getting the var, right? So sneaking ahead to one of the other features.
Fundamentally misunderstood metadata.
So yeah, so metadata is you can provide that for anything. So you can actually say with meta. I actually don't remember the arguments for doc. So let's look at the docs with meta. The object and the metadata. So if I say with meta, and then so this is my object, and the metadata is awesome true, right? Okay, so I get an object, right? So let's put that in a variable, right? Def a, no, not this a. Now if I ask for the meta of a, and remember that meta is attached to the object, not the var here, right? That's for the meta, and it gives you the metadata, right?
Okay, all right.
Right. So now if I had said def a. Right. Now now the doc string here is part of the metadata for the var, right? So the doc strings that you put in the Clojure thing go into here. So if I do meta for a, and you can see the doc, right? So that's where the docs come from. So that's how when you add if you want your docs to show up here in your source code, all you have to do is add the metadata to the def, right? Add the doc string to the def, and then the Clojure compiler when def evals, the object you get, or the var in this case, that will have the doc attached to it, and then you'll be able to get it. So when I say doc a, it gives me the documentation for it, right?
But it's part of as defined here, it's part of the var. A.
Yes, yeah. So if I do meta of a, there's no metadata, right? Because the value
a has already been, by the time the reader gets done with it, it's already evaluated.
Well, a is the value, so a is my object, right? The value of a is a var.
Pointing to the map that contains.
Yeah, that contains the value here. So let's be really tricky.
I don't want to drag this.
No. This is
down into remedial.
No. This is fun.
Remedial metadata for Steve.
So here's where's my metadata? And I hate not using Emacs because I can't get my parentheses to line up. So now if I say,
Are you still in VI mode?
What? No, I'm in Emacs mode. So if I say doc of a, or a, I get this is cool, right? Now, because it's a var, right? If I ask for meta of the var a, then I get that, right? And if I ask for meta of a, just the value of a, I should get this guy, right? Does that make sense?
Yep. Okay.
Yeah. So you got the var, and then you got the thing. So I didn't actually, I didn't actually know how that works. By the way, there is another syntax for this. Hey, there's another syntax for metadata. So if let's see, what is it? It is.
Isn't it? Oh, yeah.
It is.
Caret.
Caret. Yeah. So awesomeness 7 x. All right. So x is just a string value, but it has the meta. Meta. So it's still got that meta, right? So that's the other way you can do it. So you can actually I could actually give it a doc here too. Right. So you can specify the doc string or the meta, right? Using them. I don't think you see anybody using this like this, but you could do it. And you can also alter it. So if I do alter, just to finish alter meta, yeah, alter meta of x, and then it's a okay, dot alter. Yeah, alter meta of x, and then we need the function so. There we go. So I've altered the meta of x, and now I say doc x, the new docs, right? So because of our, you can all, that's the name, so you can alter. Anyways, just a diversion on metadata.
Yeah,
there.
I gotta go play with that.
Yeah, it's fun. And the point of all of that is just to say where do the docs, where do these docs come from, right? They come from the source code. The compiler puts that in, and you've got it, right? Now there's a couple other there's actually, if you're running NREPL, you can actually get even more docs out. So if I do cdoc of map. I think I need the symbol here. Well, okay, for some reason it's not going, but normally the cdocs should give you the all of the stuff in Clojure docs. So I don't know if I don't know if you guys go to Clojure docs all the time, but I find myself constantly going here to get the
Clojure, yes. I'm trying to get away from Clojure docs because they've been so out of date.
Well, yeah, I mean, this is it's not terribly up to date, I suppose.
The GitHub repo is active as of about 4 days ago. There is a rewrite in progress in pure Clojure that will support more current versions, but obviously it's not going to be live anytime soon.
So yeah, I actually don't know why it's not giving me the Clojure docs now. I assume I am on it. So let's try one more time. Okay, yeah, I don't know what's wrong with that. But anyway, so normally you can get all of the examples, right? So what's something else you can do then? Moving on. This is completely amazing. So not only can you find the docs for something, but if you ask, you can ask for the source for a function. So if you're trying to do, and you're saying, well, what exactly does alter meta do, right? You just ask, right? And you can see the actual implementation of it. So the question is, so we just saw the docs. Now, if you looked at the meta, it's probably pretty obvious where this comes from. I'll just show you again. meta for so whenever the Clojure compiler compiles something, it attaches the metadata, the source file, and the line number. So as long as you're, if you've got a normal code, it will be able to locate your locate your code. The only time this doesn't work is if you compile down to Java. If you generate a class with Java and you don't include the Java file along with it, because otherwise you're always going to have your Clojure file in. And you can play games with this. You can actually, using alter var meta, you could actually change the file and line number. And I mean, if you were really like, really just wanted to like annoy somebody or trick somebody, right? You could. I don't know why you'd want to do that, but you certainly could change the meta. And then when I asked for the source, it would actually go to another place. So, and this works for things you've done, but it won't work. If you do something like this, if I say, defin some function. Oh, I didn't realize there's already one there. And then I say source. I'm not going to get the source here. Why not? Because there's the source doesn't exist in a file, right? And if I look at the meta for some fun, you can see that it's, this thing is not, not interesting. I don't even, actually, is there even anything in that? I don't know exactly where that comes from. But the point is, the things that you enter at the REPL don't have that value. So this can actually become a problem for us for you sometimes, because if you're doing a lot of stuff in the REPL and you're redefining functions, your own functions that you've loaded, that get loaded normally, they'll have this metadata attached to it. So you'll be able to ask for the source for them. But if you dynamically redefine it, which I'll show you how to do later, for instance from CIDR or something like that, then you're not going to have good metadata on it. So things like source would just simply not work. All right, so a couple more things, just a few REPL tools here. We have find doc. So if I were, if I wanted to look for all of the things that find doc will search through all of the doc strings of everything that's in all the namespaces that are loaded in and find patterns. So if I find doc meta, and I find all the things that talk about meta in any way, right? So you see like Clojure.core/type returns the type meta, right? So that's find doc, and that takes a string or a regular expression. If you just want to match function names, you can use apropos, and it will show you it will only show you the function names that match that. If you know roughly what you're looking for, the combination of those two will often help you find something. I find that Google often finds the answers more quickly, based on things I'm trying to find. But it is there, and you will use it sometimes. What else does the REPL provide you here? Well, there's a bunch of these little star things, right? Star usually indicates something, either a dynamic variable or something that's locally special. One of the most useful things is star 1, 2, 3. So if you're familiar, if you use something like say an IPython or a tool like that maintains the output history for you, you may be used to being able to go back to history, but it's really pretty useful. So let's say I do something like this is for referring back to. So if I say system get property Java class path, right? So I'm getting the Java class path. I'm like, okay, well, I want to use that value. Well, obviously, I can go back up and I can construct a new expression around that, right? Like if I were working on a shell. But let's say, but instead, I want to use that value. Well, it happens to be that the last value will be stored in star 1, right? So if I want to work with that, I can do something say like Clojure string split, and I'll split it on colon here. Sorry. I can actually specify the value. I gotta actually type it right. There we go. All right, so I was able to get that value, and then I could, continue working, right? So Clojure maintains *1, *2, *3. So if I were to have like, so if I were to ask for a star, so this output here would be *1, this output here would be *2, and the one before it would be *3. So if I go back to *3, I should get the string that I was originally working with, right? So this is extremely useful. So I use primary *1 all the time. Up here, I just had an error up here a while back, and it printed out an exception. If you want to get that exception, that's *E. Right? If you're working and doing that, then you can even print stack trace, print stack trace will print out the stack, or you can pass it the specific variable either way. PST will print print stack trace will print whatever in that E, or if I were to create a new runtime exception, I could actually print out the stack trace for that. Very useful trick for actually seeing what's on the stack here. Where you're actually executing from.
What is star quote used for?
Star what?
Star quote.
That is arbitrary precision multiplication, like a plus or like plus quote, right? So if I do. Well, I guess that, does it default?
It should.
I thought it didn't anymore. Does not auto promote longs will throw on overflow.
Oh. I think.
Maybe because I used something that was already in already.
Yeah.
Let me just do something like time. There we go. So the reason when I did this, the reader already made that a big num. So obviously multiplying two big nums is fine, but multiplying two things. So this fails, but if arbitrary precision, it will automatically do it. So I think this was a change. Was this in Clojure 1.2? Do you remember? It used to be that Clojure defaulted to arbitrary precision. So if you read really old Clojure articles, they talk about this as a really nice feature, and then they realize, wow, this really slows down everything when everything's arbitrary precision by default. All right, so that's sort of toying around with some of the default features of the REPL. I thought I would show just a few things of how to get around in the REPL. So when you start off in the REPL, it puts you in the user namespace, right? Your namespace, by the way, *ns*, right? So if your prompt will tell you, but if you need it or you need it as a value, you can get to it like that. So this is if you want to change your namespace, how do you do that? You can do NNS, and I can switch to another namespace, right? You do need to quote it as a symbol, right? So that switches to another namespace, and it creates it if it doesn't exist, okay? But it doesn't put, when you use NNS, it creates the namespace, but it doesn't put everything into it that you would normally want. So, for instance, if I hit plus, right? Plus 1, 2. I don't have that, right? NNS is really mostly useful if the namespace exists already, or if you want a namespace that really has nothing in it. Now there are a couple things in here, because from here I can actually say NNS, and switch out, right? But I think this has. I didn't look into it, but I think this most likely has something to do with NNS maybe being a special form or something. I don't know exactly why, or maybe it just tries to help you and put those things in there. I'm not entirely sure. If you want to create a namespace that has everything, you can do it the way that you would do it in Clojure and use the NS form, right? When you do that, it creates the namespace and it takes you into it, but it also does all the things that NS does in a .clojure file, which is includes at the very least it includes Clojure, all the core Clojure things, right? So you've got your basics here, right? But one thing you don't have here is the ability to say, for instance, to pretty print, right? There's no pretty print, right? But we have that in the user namespace. So why is that? This is because when it starts up your REPL, so it loads you into the user namespace, and it preloads a few extra things into that namespace, like Clojure.REPL and Clojure.preprint, and a few other kind of convenience things. And you don't automatically get those when you're in other namespaces. So if you always work in user namespace, you won't really notice this. But if you're like me and you jump around namespace to namespace, then you'll have you'll start missing those things. So how do you find out what's in a namespace then? So the fastest way to one of the fastest ways to do this is to use the dir command. Dir, no quoting, no, not a symbol. Dir user. So if I say dir user, it's actually going to look in the user namespace and it's going to tell me what are all the locally defined things. So here I can see the sum function that we created earlier, right? If I were to say dir foo, the one we created earlier, I'll see. Sorry, I keep using this symbol. If dir foo, it's actually there's nothing there, right? If I let's go into foo. So set a value. Then I'm going to go back to the user namespace. Now you can see that the X is there, right? Don't be confused by the nil here. The nil is just the return value. It's actually dir is actually printing them out, and it's just the return value of the
question for you.
Yeah.
The Clojure core function, what namespace are they use? Or do they have a namespace?
They are in there. And, well, let me show you how you find this. If I type plus, it will actually tell me the namespace of where it is, right? So I can see here it's in Clojure core, right? So it's actually Clojure.core/plus, right? But okay, but let's ask ourselves: if you don't, let's say you know that you have the symbol plus, and maybe you didn't, maybe you couldn't just type the function and have the REPL tell you what it is. How could you see what's in your namespace and where things come from? If you can ask for everything that's in a namespace with NSMap. So if I ask for the NSMap of the current namespace, which is user, I get everything in here, right? So let me. Well, I probably don't want to pretty print this, right? Yeah, that's not nice. Right. And anyways, you get all of the symbols, and you can you would be able to see where all of these things come from, right? There's actually a bunch of namespace inspection stuff here, so I can ask for the NS aliases of a namespace. Aliases are when you take a namespace, when you do a require as, right? So if I were to say, so the same, when you're writing a Clojure code and you write namespace, my package, and then you do require, Clojure.core.async as async, right? When you pull in one of those guys, right? Those are the aliases. So if I were to say, so the REPL equivalent of this is require, let's say, do Clojure.string as string. I do NS aliases of the current namespace, which is user. and you can see that the string is namespace is alias for the Clojure string namespace. That means I can do string/join or right or any of those kind of things, or the string split that we were doing before. So that's where the aliases are. You can ask for your imports, NS imports. There's NS publix, all the public variables. NS refers. NS refers is actually interesting. So all the things that you refer to, not namespaces, but actual functions. So NS refers for the namespace. So this is where actually all those things like plus and things like that, key *1 and pretty print. So all of these things being things that have come in from another namespace. So you can you can see all of that stuff. How do you know what namespaces are loaded? What namespaces are loaded in your REPL? All NS. So you do all NS, you'll actually get a list of everything. So this is important because Clojure does not load all of your classes, all of your classes unless it only loads the classes you ask for, right? So let me, if we were to come over here, let's actually write some code. So I'll just make a foo.clojure. Just keep it very simple here. Restart the REPL, line REPL. All right, so if I do all NS, there's a little much in here, but basically, the idea is that this namespace over here, even though it's in my project, it's not loaded, right? Well, space. Right, I can't autocomplete on it. It doesn't know about it, right? So how do we load a namespace? How do we make sure the namespace is loaded? Yeah, so you have two possibilities here, right? Now, let's say let's start with required. Require space cadet. All right. That's not a function. So if I just ask for the value, so it's there, right? So that works. Now let's try this the other way. Use. There we go. So what's the difference between require and use then? So I've got both of them. Since you mentioned it, what's the difference?
I think one imports everything into your current namespace. The other one just loads it up. Right,
exactly. So use does that. So actually, I didn't have to type space cadet.foo/x. I just type x, right? So if I look at my NS refers, the key is sort them, so we see them. So here we see X and Y, right? Those are actually in here, right? And if I ask for the var, I can still see that even though it's a local symbol, it's really the value. It's actually a reference to the var in the other namespace, right? And if I want to switch to it, I can obviously switch over to this namespace. Right, and I've got the value. So let me ask you guys a question then. If I start up a new REPL here and I just go. And I'm sorry, this keeps switching over here because I did something to my Java that causes it to think it's a GUI thing, and it always jumps screens on me for some reason. If I do in NS space cadet with quote with symbol space cadet dot foo. Right. If I type X, should I get my value or not? No. Right. Because I've switched to the namespace, but I never loaded it. Right. So this is something to keep in mind. This is something that tripped me up all of the time when I started doing Clojure. And I just never understood why. Why? If I try to change the namespace, well, sometimes I've got my code, sometimes it doesn't, right? So you just have to be aware that code is never loaded in Clojure unless something you use asks for it. Go ahead.
So there's a third option for doing this. You didn't mention load. Load,
yes.
The raw load report form.
Yeah. So
why should you never use that?
Is there a reason not to other than it's inconvenient?
Okay, the answer I was fishing for is it's inconvenient and it forces reloading unconditionally. Use and require are lazy in compiling the target namespace. So if you re-require a namespace that's already been loaded or required once, you won't rerun the compiler. Load won't do that for you and can cause major issues if you say reload a namespace with a dynamic var in it or a hard definite you've altered.
Yeah, so that brings up some points. Is like, okay, let's talk a little bit about reloading. I was gonna do one thing though here is.
Sorry, I didn't mean to jump ahead.
No, that's good. So if I come into line REPL here, so I was just adding a dependency here, which I'll use in a second. So this is a good point. Because we've talked about reloading quite a bit in the past. So let's say I require space cadet foo. Okay. So in here I have x. Now if I change the value here, if I change x to 2, obviously x hasn't changed locally. And if I require it, let me require it again. Require. Now it's already loaded. There we go. X is still 1, right? Because exactly for the reason that if you require something and it's already loaded, it's not going to bring it up again, right? But we can do reload, which is basically what load is doing. So if I say require space cadet to foo reload, and now I ask for x is 2. So I'm going to put a print line in here, something you probably don't want to do. Foo is loading, and I'll set it to change the value here, and just show you the difference. So when I ask for it and reload, each time reload brings it in, right? And so if I ask for x, if I change it, so that's the difference, and that's how you force something to load. Now here's something that I think is really interesting. I'm going to put a require in here. So I just added a dependency. And you notice that it's pausing right here to do something. That was bringing in Clojure core async, right? So now I can do async, or if I could do say like async / go, and then I just, I'm not going to do anything in my go block. But that thing's around. I didn't know this until very recently, and this has actually helped me quite a bit, is you can actually get Clojure to tell you what it's doing when it loads something. And you do that with verbose. Not only will it tell you what it's doing, but it will actually break down the underlying commands underneath that it would be executing. So if I ask verbose, you see when I pull in Clojure, I'm going to go all the way up to the top here. I'll exit out of this so we have more room. Go all the way up to the top here. It loads space cadet foo. That required async required protocols. That required that created an alias, right? So it's doing a whole bunch of stuff, and you can see exactly what it's doing. Let me, this might be a better way to do this here. So it might be easier to have one that doesn't have quite so much so that we can see it. So let's just let's do like a more standard thing, like require Clojure.string as string, and yeah, something like that, right? So let's bring in the bar namespace. So you see it's loading it. So in ns space cadet.bar and then Clojure.core alias do that. So so you can kind of see what's going on. And so if you get like you can get in a case where you've got something requiring something, you get a big nasty project and you're like, how in the world is this thing getting loaded? Rather than going through all the code, you can get to it.
Yeah.
Yeah. So I had no idea this existed until like like this month basically. So. And it, like I said, it did save me on at least one occasion. All right, so that's sort of REPL stuff, and I wanted to sort of make sure we're good. Yeah, I wanted to. The main thing I actually really wanted to show was NREPL, because I absolutely love using NREPL in what NREPL is for. So REPL, REPL read eval print loop, right? NREPL is networked REPL, and so what's really interesting about NREPL is when you run your Clojure with NREPL, it can actually listen for connections in, and you can connect into your running process remotely, right? And so this to me is like the best thing, because lots of languages have REPLs or sort of REPL-like things. Python, Ruby, all of these languages you can start up something. And like we were talking about the Python stuff, one of the things that I loved about Python, the Python Django, or the environment that we had, is I could take my code and then I run manage.py and get into the console, and I can like be running the same code with the same database connection and all this stuff, sort of like, or the Ruby console, if you're familiar, if you do Ruby, right? And you get in and this is really nice, but I didn't even realize well, there's actually another level after that, which is like, well, you can do that and actually be in the same process that your original code is running in. So that's sort of what I wanted to show here. So when I start NREPL up, not line NREPL, line REPL. Notice at the beginning there's something up here. NREPL server started on port 62799. What's interesting about this is that is actually it's listing on that port. So I tell net localhost 62799, and I'm not going to be able to do anything here, but it's clear. It's clearly there. So I can actually connect to it. So line REPL connect, and I give it the port number. You can also specify the host in front if you want. You don't have to. So now what's interesting is we have two REPLs here, but they're both connected to the same process, both connected to this guy. So if I define a value here, and I ask for it down here, I've got it, right? It's the exact same process, right? If I define, and I'm connected to it. So that's that. So that's pretty nice. I mean, you're not normally going to have multiple REPLs, but you might be doing something like running a server, right? You're running a server, you're not going to have this first REPL, but you still have this process running, and you want to connect to it. I'm going to sort of simulate that here. Now, this REPL is going to disconnect because the server is down. If I ask for REPL, is it headless? So this would be sort of like what would happen if you were running a web application. So it's running and it's telling you that it's got the port here. So line REPL connect 62816. And now I'm actually running things here. Now I can't really see it, but if I set X or def message. This is the message. right? So it's here, but it's running up here in the process up top, right? So if I exit out, that process is still running. So if I were to connect to it again, of course, you know, again, it's a long-running process. All of the stuff that's there is still up. So this is really interesting. I would point out though, if I print line something, this is going to go to my terminal. NREPL is actually smart enough that it associates the I/O with, you know, whatever the thread is back to the client, right? So if I connect, yeah, if I do I/O here, it's not going to show up here on the server thread on the server. It would only show up here on the server if there was a thread up here started at the top that actually did that I/O.
Where does I/O go if you kick off a thread from your NREPL?
If I start the thread from the NREPL, and I don't change what system out means, it will go to here. It's not going to go to the server. Only if the server were started by something on that was running there. So if this were a web server or something, or I started a Go block in the top, then that I/O would go there, unless I did something to change that. So
What's a Go block?
core async. Sorry. So core async. It's a think of it as the thread as sort of a threading communications mechanism. So for these purposes, a thread.
It's a macro implementation of communicating sequential processes.
Yeah. So yeah, actually, I mean, I've actually got this here. So if I we could put together a test, but yeah, you'll find that it. I was really confused by this, and I thought, well, and what happens if your thread disconnects? Like let's say I started a thread here, right, a Go block here, and I were doing some I/O, and then I disconnected my REPL. Where does that I/O go? Well, it's no longer coming back to the client. So, but it doesn't start suddenly, doesn't magically start showing up in the main process console either. So it just sort of disappears. So. All right, so that's interesting, and this is a lot of fun. But I want to let you guys do this. So what I've done is okay, SSH root at REPL.stacktrace.com. So I want to prove to you. So I've got a program here. I'm running the Pi game over here. So let me start it up again, and you guys will see it start up. So I'm running a web project on this is on a machine over in DigitalOcean. It's kind of slow because it's a cheap machine. All right, and you can see it's saying started NREPL server on port 49152, and this is running here REPL.stacktrace.com. So this is the Pi game, right? So you can connect to the web app if you want to, and try to guess the 3.141926535, right? And you can play it. Or what I really want you to do is go to your console and do line REPL connect REPL.nostacktrace 49152. All right. Now, if you do this, you'll actually be connecting to my Clojure process over the internet. I've left this open on a public port, so hackers could be hacking me as we speak. Hopefully, at least some of you guys will be able to do that.
Keep your money safe inside there.
Yeah. Well, it's a virtual machine. I'll kill it when we're done. All right. Did anyone connect?
Yes.
All right. So set a variable or do something in my namespace.
All right, I did.
In
Oh,
user?
in your namespace. Yeah.
Yeah. There you go. So that was that not you? Who were you?
Did you do
Howdy?
it there?
Yep, that's me.
Howdy. Right. Yeah. So this is really, really nice. Now, of course, you don't want an NREPL sitting naked across the internet like this. You, I'll show you. It's an open port. Yeah. If you don't believe me, set one up and. Yeah. But no, and this is the process that's running the Pi game right now, right? So what I can actually do here, I'm going to exit my REPL here. I'm going to go into the local code. This is my local machine, not the So here's my tmux where I'm actually running the Pi game. And by the way, yes, you could do a system/exit1, and you would exit my process, right? Wait until the end. Wait until we're done here if you want to kill me. Wait till we're done here. So what I'm going to do is so here's my actual code. Let me go into something interesting. So here's the game. Now, if I can actually connect, and I'll just, so here's connecting through a tool. I'm not going to show you CIDR, but this is connecting from the tool. If I say REPL.nostacktrace.com, port 49152. Okay. Switch into the namespace, and let's look at the game cache. So I don't actually have pprint in here, so use Clojure.pprint. Now I can do. Now I can look in here at game cache. All right, so you can see here's the current scores. Here's the current digits. 653, 589. Right. And so I'm interacting with the app, and I can actually see the state here, right? And you guys can go if you do NNS Pi game. You guys won't have the code checked out, but you can get into the namespace.
No X11 display variable was set. I can't pop up a window in here.
Capital X.
Well, you can still run things. You can start threads, do whatever you want. I'm pretty sure there's nothing you can do that's going to get me charged any extra money. So that's really cool, and I could actually change. I could actually run code. So let's see, where's the guest function? So I could actually call do guess and simulate some of these things. So does anybody? So this is cool. So I'm going to leave this up and running. You guys feel free. Feel free to rewrite my application, fix some bugs, do whatever you want here. What I want to show you is okay, this is kind of cool. Let me actually show you this running. This is a real thing. It's out on the internet. Oh, somebody's guessing. The secret is just to bang on the keyboard. Okay, so what I want to actually show you is this is my threat grid. This is my actual day job, right? So here's our login screen. So what I actually want to do is I show you how we actually use this in the this is not just toying around. So the first thing I'll point out is that I am connected to my VPN right here. So we obviously we don't have NREPL ports sitting out to the world. We have we protect them as well as put it behind a VPN. If you didn't have a VPN, you should limit it to localhost, and then you'd have to SSH tunnel in. So that's what we're gonna have to do, both of those things. So I've loaded up my code base here. Let me get into the code for the login screen here. And then, let's see, I'm going to need to open the tunnel here. So I'm going to connect through my SSH tunnel. Port 5555, which is what I port mapped to. Sorry. All right. And then, so I can actually do things like welcome Austin Clojure. And I've just live patched staging, right? You know, or staging. We can do the same thing in production. I'm going to change it back before anybody at work actually notices. So all I've done is connected via NREPL. I'm telling my tool reload this command. So it takes the source code, sends it over NREPL, runs the def in the right namespace, evaluates it, and I reload the page, and I've live patched the server. So we do this quite a bit. It's amazingly good. You have to exercise a lot of discipline, but when we've got something really tricky, I can actually even get into, I've actually live debugged in production through here. Like, you know, we've got like API calls that are going wrong. I can put some debug code, put some tests in. I can actually load that code into production, capture the actual problem, then I can reload the original code, get it back into its original state, and without restarting, without recompiling, without doing anything. Not something I recommend doing on a regular basis, but there are a lot of times that it turns out, you know, with some discipline, it can be it can be extremely useful and relatively safe. So. This is why being able to connect in through the REPL to the production and do this. I mean, this is for me the thing that makes Clojure Clojure is already a great development experience, but this is what makes it such a great production experience in my opinion. After doing this, when I go back and work on, for instance our Go code that we were talking about, the Go code we can't do this to. It's just static servers, and when we make a change, we have to recompile, stop the process, and run it again, right? Well, anything is possible, I am sure, but it is not line REPL connect and run, right? So, anyways, that's pretty nice, and that's by far my favorite feature. Did anybody kill me yet here? No, nobody did. Okay, so I'll kill myself then, unless somebody else wants to.
Check your terminal.
Check my terminal?
Yeah. I think I maybe should write something to the team members.
Here? Yeah. If you put something in the function, so if we wanted to change, let's see, where is that? So if I put some extra things here, reload that, and then oh, there you are. Hello there. There you go. So yeah, as long and the IO will come here as long as it's, you know, all this stuff is executing on the main web thread, right? So that is pretty cool. And of course, if you want, well, let's see, where's my, system exit one would be how to. I won't actually do it, but that's how you do it. So that's all I really had. I think that the experience, well, playing with the REPL again. Oh, there, somebody did it. And now the app is down. There you go. You just see my Nginx there. I will. You're gonna have to kill me a bunch of times now. There you go. It'll take a second to come up, but that's that. I find NREPL again. It's a very powerful tool, and I enjoy it. So, did anybody have any other REPL questions to go over? All right. So I guess if nobody has anything, we can just go downstairs a little bit early, and chat. Do try it though. Once you start getting used to the pattern of being able to connect into a process and edit live, and I mean I don't know how you guys when you're coding Clojure, if I see a lot of people doing like reload and just very manual things, or just relying on like rings reloading or something like that. But this is how I develop. I mean, what I've shown you here, all of these patterns, this is what I do pretty much every day in my Clojure. And of course, if you're looking at something I did and saying a better way, please let me know. I'm always open for a better way.